The title is Smart Solar Energy Harvesting, Storage, and Utilization. And the project is coordinated by Professor CP1 until 2018 summer, and then I continue to serve as a project coordinator and until the end of last year. And so, as we know that most of energies on the Earth come from the sun. So solar energy is about 6,000 times the energy we use at today. So if we use part of that, actually, this is very, very important to fight for this global climate change. And so the project here, actually, we have several goals. First is to develop and optimize this PV modules with a vacuum deposition technique, and also with earth abundant materials. And also we developed this solution process thin film PV devices. And also we developed some lighting trapping schemes for photovoltaic to increase the photovoltaic efficiency. And also we have developed some artificial photosynthesis techniques. And meanwhile, we have developed some batteries for energy storage, particularly for high performance battery, redox flow battery, and these so-called supercapacitors. Meanwhile, also we try to develop some new technology for microgrids for energy distribution. And also we built this field demonstration I will show you later. As we know, this solar cell technology has been developed for about 40 to 60 years, from single crystalline silicon, and then the thin film PV, and then nowadays we call the nanostructured PV. And the key issue actually here is how to utilize this solar energy, okay, through the harvesting to the utilization. So here actually there's a gap, how to efficiently use this solar energy. And here actually we use so-called holistic approach, and to combine this harvesting part with storage part, and then eventually to develop this microgrid utilization system. And we have about 6 subgroups dealing with energy harvesting, and then energy storage, and then also this utilization. We have 4 universities involved in this project, and with about 60 million Hong Kong dollars supported by RGC. As I mentioned here, we have actually 6 teams and subgroups, and then consisting about 20 professors. And this actually the budget is we have some funding from the RGC, and also we have a matching from the different universities. And in terms of project management, actually we have this project coordinator, and then we have we had this project manager, and then with the team members, and then we have different committees, and also we have arranged a series of workshops and site visits and so on. And also we had the advisory board consisting of renowned scholars on this energy harvesting and storage and the utilization coming from different continents. And so far we had about 150 students and also these register members involved in this project. So now here I would like to highlight a few major academic or technical achievements. And we have about published about 300 international journal papers, and amongst them 40 are selected as highly cited papers, and with a total about over 20,000 SCI citations. And for this energy harvesting, as I mentioned, we have a team and led by Professor Shell and working on vacuum deposit thin film PV cells and the modules. And they have built up these systems here for research purpose, and particularly for this copper zinc tin sulfide, this new type of solar cells with abundant this earth abundant materials. And this actually is a device structure. Actually, there's a so-called this light absorber, and the key point is actually is try to optimize this buffer layer and all the whole structures with this back electrode and top electrode. And this actually summarize the development from different groups and worldwide. Okay, it's at the moment it's actually we have about it here. Okay, it's the best in the Greater China, but it still is not the top one in the world. It's top one at the moment is from Germany. And so in 2014, a team led by Professor Shao and in CHK and also in collaboration with CAS, and they have produced one of the highest efficient this solar cell at that time, and also they built these modules, and this actually is a very high efficient modules for practical this can be for practical applications. And this actually is last year they published the result with a 20.19% this CIGS solar cell with a new buffer layer. Okay, it's a zinc and oxygen and the sulfide. For this solution-based solar cells, and we adopt this multi-scale approach towards high-performance perovskite solar cell with a low cost. And actually, we have tried to modulate this composition and also surface passivation and also morphology optimization. And here I just give you one example is by Professor Ni Zhao's group. Actually, they introduce this chlorine into this thin film. So eventually, this chlorine will be released, and eventually you can achieve a very high quality thin film. And this work has been highly cited. And also, her group developed this intermediate material, and then in order to actually to have achieved the high quality this perovskite material, you can see here with a very clean this crystallinity and a high this performance. And our group actually, based on her work, actually we developed this so-called this MA vapor process. And again, we have to use this intermediate material. And the lifetime can be extended, more than 10 times or even 100 times. And also one of our team members, Professor Yan, actually discovered that the solution for this material, this so-called precursor, is not a real solution. Actually, it's a colloidal. This actually opened up a new this so-called colloidal chemistry and coordination for this perovskite materials. And also the work has been highly cited. And here just show you by modulate this this composition, actually we can achieve a very good this so-called surface morphology. And also Professor Zhao's group had developed this a new scheme to passivate the thin films with this so-called benzene amine. Okay, and then you can see the lifetime has been extended many, many times. And Professor Henry Yan from Hong Kong UST and discovered this new class of material we call the non-fullerene materials. Actually, is this one to replace conventional this fullerene-based material. This actually is a very expensive one, and this actually opened up a new area, and the paper has been highly cited, and also he has received a big award recently from this Tencent Foundation. And meanwhile, his team developed also the new material, and based on new mechanism, so-called temperature aggregate this phenomena. So at a low temperature, you see this aggregation, and the molecules looks like this arrangement. And then at a high temperature, we have this dispersed this molecular configuration. So in this way, actually, for this molecule, small molecule-based this solar cell, actually you can achieve the optimum this so-called this device performance. And in early 2015, his team actually created a work record, and with this efficiency about 11.7%. And now this year, actually, the CTU team from different project, okay, they achieved 17%. This actually is very, very high. It's actually unimaginable many years ago. And also to find these alternatives, these materials actually for alternative solar technology, Professor Wang's group actually discovered this so-called the new material. And for upconversion, that means to convert this infrared light, and then to shine this material, you see there's a white light emission. And also they verify that the efficiency can be as high as 16%, which is a world record so far. And here just show you the demo. Actually, they shine the laser beam, infrared laser beam, and then generate white light. And this white light can be collected by this solar cell, and then eventually to drive this LED. So, and then you see this LED, this light emission. And also they can demonstrate this to drive this fan, okay, with this infrared light. And also they develop this gold nanoparticles to realize a new chemical reaction, okay, based on so-called plasmon-induced this reaction. And meanwhile, Professor Jimmy Yu's group developed this new material. We call this microfibrous red phosphide. This actually is earth-abundant material to produce a clean fuel, basically the hydrogen, with a very high efficiency. Actually, you can see this yield is very, very high. And so here actually you can see the hydrogen bubbles. And this paper certainly has been highly cited and draw great attention worldwide. And here this actually is earth abundant, this red, this phosphor as this chemical reactor. In terms of energy storage, and the Professor Lu's group and developed this so-called redox flow battery. And the principle actually is here is to try to increase the number of electrons from ions, at the same time to increase the concentration of this electrolyte. And eventually they achieved high performance aqueous based batteries and also non-aqueous based batteries. And here is 2015 is her group achieved this very high efficient, this we call the volumetric capacity of this non-aqueous redox flow battery. And later on, they developed this new so-called semi-solid liquid non-aqueous redox flow battery. Again, you can see this the capacity is the highest. And later, actually, they developed this aqueous all liquid redox flow battery. Again, you can see this energy density again is one of the highest. And recently, actually, they have developed this hybrid aqueous redox flow battery, basically partially replace iodine by bromine. So eventually, they can further increase this um, capacity. And the Professor Nizar's group actually developed this new type of this supercapacitors by introducing these asymmetric electrodes. And here actually just show you they introduced a 3D curved graphene in order to increase so-called this surface volume ratio, and that's shown here. And this actually also they developed some metal oxide, okay, and the nano structures, and then in order to increase this so-called this performance. And here just show you this actually this power density and also this energy density. Now this actually the team achieved one of the highest in the world. And this is a morphology of this the porous carbon foam they developed by the team, and this can be used for many different applications. Again, this just shows the performance, the summary here that the team achieved at the moment. And in terms of utilization, and the Professor Minhua's group have developed a new paradigm for scheduling, and they call this CIGS. And it turns out this algorithm can be used to minimize this cost by 20% in comparison with conventional this technique. And so actually the microgrid is very important for this renewable energy, particularly for wind and also for solar, because of the nature of intermittence of these energy resources. So the microgrid is a very important and a reliable and efficient technique. And actually, you will see later, they apply this software to this to the CTU, this real testbed, and indeed they have achieved very good result. You will see. So Professor Xu, and now he's here, and actually his team developed this so-called smart grid lab in Hong Kong, and with this hardware and software, and also this real implementation. And this actually is a test bed in the PolyU, and then this is a architecture of the whole system, okay, including this solar, this harvesting, and then this scheduling, and also this electrical demand, and then also this measurement monitoring module, and as well as this computer, this actually this control and system. And also the team has developed so-called this smart demand controller as shown here. And so this actually can be very useful for the microgrid. And this actually is the team in the PolyU, led by Professor Xu. In terms of technology transfer, actually we have several granted patents for this photo solar energy harvesting and the storage and so on. And this actually is a pipeline, this pilot line is in 2014, and in collaboration with Chinese Academy of Sciences. And this is for this large, this glass substrate. And this is a module. And later, actually, Professor Shao set up a company and to produce this solar cells on flexible substrate, particularly this one actually is a rollable thin film solar cell power bank. Meanwhile, Professor Yan set up a company in Science Park called this eFlex. And then this also, the company produced solutions for flexible solar cells, and they are lightweight and also rollable. And also Professor Daming Zhu and his team developed this so-called smart metering system in CHK for this hostel, college hostel. And this actually is this kits, and then this software. And also we have conducted a few demonstration with microgrids and also this PV as you hear. And it turns out after 4 months test, so this system generate 13,600 kilowatt hour electricity to supply this hostel. And this amount is around 2.4% of the total power consumption of the entire college. And also Professor Xu's group also developed this so-called granular probabilistic interval forecasting, and in collaboration with Hong Kong Observatory. And we actually achieved many awards in the last 5 years also, and also international recognitions. And also some students also receive a best paper award and so on. So in summary, so in this project, we have developed and commercialized this high performance CIGS thin film solar cells. And also we established this interdisciplinary research platform and for devices. And also we have developed this this class of organic materials for this novel PV. And also we have developed this high performance energy density, these batteries. And also we have developed this new software, and actually it's a paradigm for scheduling of these microgrids. And also we have this field demonstration for the combination of harvesting and the storage and also utilization. So with that, I would like to thank you all for the this attention, and also I would be happy to to answer any questions relevant to this project.
So I see the first question from Professor David Hill. How can the research like this project influence Hong Kong to higher uptake of renewables?
Yeah, it's at the moment is as I mentioned, we just show this to these companies. I think particularly this one located in Science Park, and I think this technology, if can be as widely accepted and utilized, and then this should be very useful and very encouraging.
Maybe I can say something about this influence to Hong Kong. Actually, in this project, especially for our part, the subtopic 6, where I'm leading, we have actually developed a very comprehensive demonstration platform for the microgrid with EV, not EV, with PV and other distributed resources embedded in the grid, and we can achieve full scale operation, including grid connected or isolated operation in our platform. And this platform is also able to carry out all kinds of operation analysis. So I believe this platform can serve to demonstrate as well as to test all kinds of advanced algorithms concerning grid connection of renewables in Hong Kong. I mean, power grid issues regarding the renewable and actually we are collaborating with the MSD as well as the two companies. Already we have some projects ongoing using this developed platform. So the second question I'd like to from the audience is how are the companies funded based on this technology by these researchers evolving?
Yeah, I can answer this question. Actually, the two companies founded by this professors from CHK and also from Hong Kong UST. And so actually this the company is running in Zhejiang. Actually is still in the good shape at the moment for this niche market. Actually, is for this rollable this uh, solar batteries. Okay, and so I think this also is a question 3. Okay, it's basically for this solar this harvesting. So I think at the moment there are 2 companies now. And for the rest part, I don't know at the moment for this storage, because Professor Lu has another project working on this high performance this battery. And but anyway, they have some patent has granted. Okay, I think the U.S. patent. And yeah, another question is for the final project product. As again, as I mentioned, the company actually is produced this product for this rollable solar cells at the moment. Okay, so I can show you this. You have this product. Is here is actually this one. Okay, still I think. Yeah, this one. Okay, certainly is. I don't know at the moment the volume. Okay, to be honest.
So there's another question. So what is the main challenge you are finding in the process of commercializing these technologies through the companies that have been created by researchers? Also, how are you dealing with the top challenge?
Yeah, it's it's because it's concerning about this. Yeah, you're right. It's actually they are very challenging, for this commercialization. And I know that Professor Shaw actually struggled for very hard, to get the money from different resources. And it's indeed it's actually you have to find out first is a technical niche, so what you can do, okay, and and then you can come up with some new solutions for this, for example, for the large area deposition, and then to minimize the cost, and then to find this funding sources, to fund this project, particularly for to run the company. So you are right. This is actually it's not easy for academia and so on. And but anyway, I think at the moment they still it's quite successful, and I hope the company can can develop to healthily, and with this very severe the competition environment at the moment.